Today we are a group. We're going to discuss water consumption on plants and washing cars. On average, how much is being wasted of what are you trying to reduce? On average, water consumption on plants and cars. When it comes to plants, overwatering is a common reason for water to waste. Frequently, overwatering plants can cause runoff and water loss. All gallons of water are being wasted in which a plant only needs around 1 liter of water for plants. To avoid overuse of water, water waste can also be caused by ineffective irrigation techniques, such as sprinklers that shoot water on the garden over a wide area. When it comes to washing cars, the average amount of water that is being wasted is around 7,000 gallons of water per day. What are the consequences of these ecological footprints to us and the planet if this continues? Water scarcity. Excessive water usage can cause droughts in some areas, not only for humans, but also for the ecosystem and wildlife population that rely on water sources. Environmental impact. Excessive use of water can lead to adverse effects to the environment, such as depletion of aquifers and lower of water tables. It can impact on heavy bodies of water like rivers, lakes, and wetlands. Water pollution is the next one. As the water is used in washing cars, pollutants such as oil and chemical agents can be carried off into some drains and contaminate the natural water bodies. Impact on biodiversity. Shortage of water availability and polluted water can harm our biodiversity, including aquatic plants and animals. It can disrupt the ecosystem and lead to decline of distinct species.
The third question is, besides your plan of reducing the specific ecological footprint, what green technologies are present to continue to help reduce this ecological footprint? So we have list here. First one is the rain water harvesting. Systems for collecting and storing rainwater are installed on roofs and other surfaces. Second would be gray water recycling, is the process of reusing water that has been likely used in sinks, showers, and washing machines. Gray water reused may lower the need of fresh water by reducing the need for irrigation and toilet flushing. The third one would be low flow fixtures. By installing low flow toilets and shower heads and faucets, you may drastically cut your water usage without sacrificing performance. These fixtures use less water each time, which result in significant long-term water savings. The fourth one would be drip irrigation system. Drip irrigation system minimize water loss by evaporation of rain runoff by delivering water directly to the root zone of plants. Fifth would be smart irrigation controllers. These controllers change irrigation schedules depending on real water demands, preventing overwatering and boosting water efficiency. Six is serescaping. This landscaping technique makes use of locally grown drought tolerant plants that need less irrigation. It lessens the demand of irrigation and promotes water efficiency. Seven, water purification and or what do you call the water recycling system. Water recycling system may be used in business and large scale enterprises to clean and reuse water for a variety of activities, lowering total water use and wastewater output. Another one would be desalination in areas where there is a serious lack of fresh water. Desalination technologies transform salt water into fresh water. Desalination technology develops or make it more sustainable even if it might be energy intensive. Last one, or the ninth, number 9 in the list would be water purification technologies. Modern water purification technologies may cleanse and purify contaminated or polluted water sources, making them suitable for reuse or consumption. And the last one would be water monitoring system. Using smart water monitoring system can optimize water use, find leaks, and uncover inefficiencies, resulting in improved management and conservation. And number 4, it says here, describe how these green technologies work. So the first one with the rainforest harvesting, gutter, downspout, and storage tank system make up most rainwater harvesting system. When it rains, water is gathered from rooftops and other surfaces and channeled into storage tanks or cisterns via gutters and downspouts. The second one would be the gray water recycling, is the process of gathering water that has been little used from sources such as sink, showers, and washing machines. And gray water is routed to the treatment system via separate plumbing, which may include simple filter and disinfection procedures. So following treatment, gray water is kept in a separate tank where it can be utilized for non-potable tasks like flushing the toilet or watering plants. The third one is the low flow fixtures. Low flow toilets, shower heads, and faucets are made to use less water while still performing adequately. To simulate a high flow while using this water, low flow faucet, for instance, utilize aerators or flow restrictions to mix air with the water. Depending on the kind of waste, low flow toilets utilize various flushing methods, such as dual flush system to give variable water amounts. Fourth would be drip irrigation system techniques. The drip irrigation techniques are use emitters and tubbing to distribute water to the root zone of plants. The emitters accurately and gradually discharge water, reducing runoff and evaporations. To assure the best water distribution, this system may be automated and managed with timers or sensors. Fifth one is the smart irrigation controllers. Smart irrigation controllers modify water schedules based on real-time meteorological information, soil moistures, sensors, and other inputs. These controllers can optimize watering timings and durations to meet the real water demands of plants, preventing overwatering by considering variables like the temperature, humidity, and the precipitations. Six is the xeriscaping. Um, it says here that xeriscaping entails selecting native drought toilets plants that are suitable for the area's environment. This is less need for irrigation since these plants have evolved to require less water to live. Additionally, xeriscaping could involve employing drip irrigation system and mulch to keep soil moisture in place. 7. Water recycling system. In industrial context, water recycling system may require multi-stage treatment procedure to make the water appropriately for reuse in various processes. Impurities, contaminants, and pollutants are removed from it during treatment. Advanced treatment methods including reverse osmosis, activated charcoal, filtration, and UV disinfections may be applied depending on the application. Number 8, desalination. So this process, such as reverse osmosis or distillation, purifies salt water by removing salt and other contaminants, while distillation requires boiling salt water to produce steam and then considered it back into fresh water. Reverse osmosis involves push seawater through a membrane with the help of high pressure pumps. This procedure generates concentrate brine as well as fresh water, which must be properly disposed of to minimize any negative effects on the environment. Nine would be water purification technologies. Depending on the degree of water pollution, several water purification technologies can be used. Filtration, sedimentation, coagulation, disinfection using chlorine, UV radiation, or ozone, and sophisticated treatments like activate carbon adsorption and membrane filtration are example of common techniques. Last one would be water monitoring system. Water monitoring system measure water use, identify leaks, and evaluate the effectiveness of water utilization through sensor and data processing. This device can assist identify areas for environment and offer real-time information into water consumption trends. By putting these green technologies and practices into practice, we may dramatically improve water consumption or conservation and lessen the environment impact of your water use.
Fifth is critique of the use of green technologies for water consumption. First is cost. Green technologies can be expensive to implement, potentially limiting adoption. Next, complexity. Some systems are intricate, requiring specialized knowledge for installation and maintenance. Next, energy consumption. Certain technologies may need energy input, offsetting their environmental benefits. Next is location stability. Effectiveness varies based on regional climate and water availability. For behavioral factors, user cooperation and behavior changes are crucial for successful outcomes. Last is scale and scope. Proper sizing and application are essential for maximum impact. 6. Are these green technologies useful to the average person? For individual savings, green technologies can lead to reduced water bills and cost savings. And environmental awareness. Using these technologies promotes eco-consciousness and sustainable practices. For access to resources, they offer reliable water resources, especially in areas facing water scarcity. Next is maintenance and expertise. Professional support is vital for proper functioning and upkeep. Last is behavioral change. Green technologies encourage water savings, habits, and mindful consumptions.
Okay. The seventh question is, how are various countries dealing with this ecological footprint issue and possibly without the help of money or green technology? So different nations are using different type of techniques to solve the problem of water consumptions. First, set limits on water footprints. Governments can control the amount of water used in each river by setting the limits on the footprints, like how much water is used by each sector. It should be limitless. Increase awareness. Increasing people knowledge of water sustainability concern connected to water consumption can help pursue people and companies to utilize water more wisely. The objective and scope of research can be met by a water footprint assessment. Reduce water pollution. The water footprint counts both the volume of contaminants water as well as consumptive water consumption. As a result, decreasing water pollution can aid in decreasing the water footprint. Fair distribution. Having a water footprint has advantage over having a carbon footprint. Water is necessary for creation of food we eat, the clothes we wear, and the material needed to construct our houses. In order to ensure that everyone has access to water, water resources must be distributed fairly. It is crucial to remember that the problem of water consumption ecological impact is complicated and necessitates a diversified response. To solve this issue successfully, nations may need to combine these measures with others.
So, next is what are the ethical issues surrounding these green technologies, society behavior, and global impact. The introduction and use of green technology are intended to promote environmental sustainability. Still, it can raise several ethical issues related to global impact on society behavior and water use from factories and car washes. The first one is water availability and equity. Green technology involvement in wide-reaching renewable energy projects and biofuel manufacturing needed vast amount of water, which uplift the ethical dilemma related to equal distribution of water resources that ensure water-intensive technology do not incorporate effect on water scarce areas and communities. And the second one is sustainable water management. Ethical conservation ensures that environmentally friendly technology are developed and used to promote water conservation and responsible water management, which include recycling water, implementing green water harvesting. And the third one is consumer behavior. Green technology has the potential to reduce the environmental effect. However, as a result, they may have negative consequences such as rebound effect. For example, people can observe how they conduct themselves to become more ecologically friendly, and it aims to illustrate the evident benefit of these technologies by considering boosting automatic water use. And the next one is environmental impact. Developing and adopting green technology can have unintended environmental impact on local ecosystem and biodiversity. For example, hydropower project can alter river ecosystem and adversely affect aquatic life. And the next one is greenwashing. It is an unethical marketing practice that involves some companies misleading the environment benefit of their technology, including water-saving feature. They manipulate in their customers, making ill-informed choices, hindering their ability to make genuinely sustainable decisions. And the next one is life cycle concentrations. It is crucial to access the complete lifestyle of green technology. For instance, the production of solar panel and electric vehicle which necessitates water, energy and raw material potentially impact the environment and society. And the last one is responsibility and accountability. Managing the impact of green technology on water use raises complex ethical dilemma. A cooperative approach is vital, involving diverse stakeholders like government, business, and individuals working together to find inclusive solutions and address these challenges effectively. So thank you all for participating in this presentation. We are end with our presentation. Thank you.